So here with our first problem, we're trying to find the distance between 2 points. The problem says that segment MD has a midpoint of x at 3, 9, and M has the coordinates of -3 and 4. Now segment RG has a midpoint of y at -13, 8, and G has the coordinates of -3, 2. Now it wants us to calculate the distance between R and D. So now we're taking the problem I put on the previous slide and actually solving it. So we have segment MD with point M being at -3, 4 and the midpoint being at 3, 9, and we have segment RG with point G at -3, 2 and the midpoint at -13, 8. So to find point D, we have 2 points already, and we know that the midpoint is exactly halfway in between M and D. So I just did this in my head, and you can too. -3 goes to 3, so then D would be 9 for the x coordinate, and then 4 goes to 9, so D would be 14 for the y coordinate. So D would have coordinates of 9, 14. And with segment RG, you have segment G has the coordinates of -3, 2 and -13, 8 is the midpoint. So for the x coordinate, you have -3 and then you have -13. So the point that would align those two perfectly would be -23 for the x coordinate, and for the y coordinate 2 and 8. So you would have 14. So you would have 14, 8, and 2 would be mathematically proportional. So now that you've found points D and R, you can plug it into the distance between 2 points formula and find your distance between RD, which is what the problem needs. So you know that D equals 9, 14 and R equals -23, 14. So you would plug the x coordinates in for the first aspect. So you would do 9 minus -23, but two negatives become a positive. So you have 9 plus 23 for the x coordinates squared. And then for the y coordinates, both coordinates equal 14, so you wouldn't have any difference. So you would have 14 minus 14 squared, which is 0. So you would have D equals the square root of 32 squared plus 0 squared. When you calculate that, you get 1024. And then the final step is you simplify that by taking the square root of 1024, which is just 32. So for this problem, the final answer would be the difference between RD equals 32. For this next problem, we're going to calculate the distance between midpoints of segments, not two specific points on the edges. So for this one, we're using coordinates with 3 numbers instead of 2, but don't worry, it won't be that much more difficult. So for the first segment, MD, we have coordinates of M at 0, 10, and -3, and D at -2, -7, and 13. And we have segment RG with coordinates of R at -4, 3, and 11, and G at 2, -1, and 12. So now our job is just, like I said, to calculate the distance between these two midpoints. For this problem, since we're trying to find the midpoint, and we have both coordinates on the end of the line segments, we're going to use the coordinates of the midpoint of a line segment with endpoints formula, like the one listed on the screen for the first step, so we can find the midpoints and then solve the problem from there. So now we're going to input that formula to find the midpoints of both segment MD and segment RG. So first we'll find the midpoint of segment MD. So with X, we have coordinates of M at 0 and D at -2. So we take, with following the formula, we take 0 minus 2 and we divide it by 2 and get -1 for the X coordinate. Now we do the same thing for the Y coordinate. We do 10 minus 7 divided by 2, and that equals 1.5. So now the y coordinate is 1.5. And now we do lastly we do the same thing for z. So we have -3 plus 13 divided by 2, which equals 5. So when you put all those together, you have a midpoint at MD of segment MD at -1, 1.5, 5. So that's segment MD. Now for RG, the x-coordinates of R are -4 and the x-coordinate of G is 2. So you have -4 plus 2 divided by 2 equals -1. Then for Y, you have R is 3 and G is -1. So you have 3 minus 1 divided by 2 equals 1. And then for Z, you have R at 11 and G at 12. So you have 11 plus 12 divided by 2 equals 11.5. So for segment RG, the midpoint as listed at the bottom of the screen would be -1, 1, 11.5. So now you've found the midpoints of both segments, and now you're going to use what you found to calculate the distance between the two midpoints. So now on this slide, I've typed out the both midpoints that we found on the previous slide, midpoint of MD and the midpoint of RG. So we're going to find the differences of each individual coordinate x, y, and z. So for MD, we have the x-coordinate at -1, and RG is at -1 as well. So the difference of that is 0. And then for y, we have 1.5 and 1 with a difference of 0.5. And for z, we have 5 and 11.5, which is a difference of 6.5. So when you plug it into the equation for x, you have 0 squared plus y 0.5 squared plus z 6.5 squared equals the distance between two points, aka the midpoints. So now we're going to use the distance between 2 points formula with the numbers that we found on the last slide. So now we're just plugging everything into the formula. So we have 0 squared plus 0.5 squared plus 6.5 squared, x, y, and z. Those are the values. And when we put this into the calculator, we get 42.5. And now the last part is to take the root of 42.5 because you want to simplify it as much as possible. So the distance between these two midpoints is 6.52, and that's the final answer.